Now we are moving towards our second session. I would like to call Mr. Lalit Bajare, the Chief Technology Officer at Innovative Water Technology, Pune, to deliver a session on patent sewage treatment and technology. Thank you so much, sir.
Good afternoon. My name is Rushad. That's Lalit, who was introduced. I'm just the stepney that comes along with him. So, Rushad here. Right? We are representing a company called Innovative Water Technologies. I hope everybody at the back can hear me. Right. So, just to give you a quick heads up, and in relation to the time that we have in hand, I'd like to keep this as short as possible for two main reasons. One, obviously, the sewage treatment plant, the packaged sewage treatment plant that we're going to introduce here is called FB Tech. It's a patented technology and the only Indian brand that has been currently empaneled by the Jal Shakti Ministry. The only Indian brand that has gone through a scrutiny for about 6 months, which lasted about 6 months in the year 2021. That committee was headed by the principal scientific advisor to the PM. In that body, there were about 38 members, comprising of the DRDO, IIT professors, NITI, NIRI. All those people came together to create or to find an innovative technology in the space of water treatment. And we were glad that in the year 2021, we were the only Indian company to be empaneled. And you'll hear me saying that a lot because I'm very proud of it. Right? Thank you. So I'm going to take you through the first slide, and then I'll introduce as we go along. The technology part will be spoken by Lalit. I'll take this opportunity to also tell you one very important factor. This technology that we talk about is an absolute brainchild of Lalit Bajare. He is the gentleman who has created this technology from cradle to where it is today. And I think the best person to give you any kind of information from the technology front, from the specs, especially for the BMC team if they were here, or anybody from the technology team that is here, he's the best person that could give you an example, not only on our technology, but also the comparison between the conventional technologies that currently exist in the market. Now, as far as we are concerned as a company, the biggest challenge we face is we have a go-to-market strategy where if we were a regular product, we had a plan for entry. But right now, the biggest challenge for us is like what the electric cars faced 10 years ago. A new technology, we don't only have to get into the market, but we have to educate the people on what we are. And then try to change that mindset from comparing us with conventional technologies as compared to what we are in reality, right? So that's where Gulkani Saab and I know Salvi Bhau and all the other panelists would be of great help, and we're looking at channel partners and liaison partners to help our business grow, and not only in India, but across the globe, right? So, our main objective when we created this technology was to unlock economic value through this whole water treatment. Now, we work on 3 bottom lines. This whole company was formed and the product was formed on 3 bottom lines. We look at the planet, we look at the people, and we look at profits. Now, don't call me a capitalist, but even if I was an NGO, if I wanted to last the next year, I had to make some kind of money. So the point here is we had to look at that because at the end of the day, as I mentioned, we are compared with conventional technologies. And we had to be in a space where we were competitive in terms of pricing, but at the same time, we were effective and efficient in terms of the treatment goals. And as we go along, you'll realize how we achieved that. As far as the people are concerned, we believe as an organization that no matter who we are dealing with, whether internal or external stakeholders, everybody must be in a win-win situation with our business. And we look at profits not in the short term, we look at profits through creating a kind of a value for our customers. We want to achieve the goals by not only helping our clients to direct, but also working in line with the global as well as the local government regulations. And you will also realize when I talk to you later in the slides how we've achieved that. I'm going to share with you a quick question. Why wastewater management? I think Salvi Bhau spoke in depth about it, but I'll try to take it very quickly in 30 seconds through one slide, just to put numbers there, realistic numbers. Let's presume there were 1,000 people in one building. Now that number is pretty straightforward in Bombay today. A 25-story apartment building, 4 apartments per floor, excuse me. We're talking about average 4 people per apartment. We've got 1,000 people. 1,000 people on a conservative level, right? The government states per head, you should calculate 140 liters per person per day. I'm taking it at 100, being conservative with the number. You're talking about that building alone using 1 lakh liters of water a day. In conclusion, to give you some semblance, it's about 5 BMC trucks or tankers, right? Out of this water, 81.4% of the wastewater generated goes to water bodies. As per the report by Niti Aayog, very recently, a couple of years ago, only 18.6% of water is being treated in India across the globe. Now, in some urban areas, that number could be as high as 32%, but in some rural areas, it could be as low as 4 to 5%. However, the big concern or the point that we are trying to drive home is, out of the water that is treated and recycled, how much of it is reused? And that number lies as low as 2%. As per the Niti Aayog and as per the NGT model, they believe that they want to reach about 30% of reused water by 2030, and that's what we want to support. This number of 81.4% is still a huge number and needs addressing. Our aim is to take 100% wastewater treated, recycled and reused at source. Now, this word that I just mentioned to you, at source, is the key word here, because we are a decentralized plant. Okay? And the beauty of a decentralized plant, as we go along, you'll realize, the commissioning time is faster. We require less capex in terms of land or in terms of capital invested. We require less operation cost because of the way it has been designed. And as we go, I'll mention this to you right at the onset, and I'll feed to those points later as we go along in the conversation. This entire R&D process has been done in Indian conditions. So let me give you an example. When we did the R&D research, we realized that this space of 5 KLD up to 2 MLD, I beg your pardon, is the space where there is no fixed technology. And if there is a technology in place, the treatment goals are either not up to the mark or they're very expensive, right? So as we go along, we can ask those questions, but in the constraint of time, please find me in the lobby or Lalit, and we'll be happy to give you examples or answers on that too. Why wastewater management in India? India is, as Salvi Bhau mentioned some time back, India is world's most water-stressed region, and this is about 600 million people today are facing extreme water crisis. By 2030, that is, I think, 6 years from now, the demand of water will be twice as much as the actual supply that we have in India itself. Okay, now we need this addressing for 2 main reasons. It's going to create a major crisis for us, but what it also do is, it'll have an impact of somewhere close to 6% on our annual GDP, right? So that's one area that you need to look at. India's current sewage capacity is 18.6%. Now this again, I mentioned to you earlier, but I'd like to state a point here. There was a report that came out as close as 2021 by the Central Pollution Control Board, which stated that the Ganga Action Mission and the Yamuna Action Mission, I'm sure everybody's heard about that, right? Only 7,000 million liters per day is actually being recycled, as well as whereas the capacity that is put in place is 33,000 million liters a day. So what I'm trying to explain is about 25% is the only working capacity, about 75% is inop for various reasons. Commissioning, the kind of resources that you require to run the plant not available, the funds that are required to maintain the plant not available, the specialized kind of people that are required to run the plant not available, and the reasons can go on, right? The maintenance cost that it takes to run a plant which is like 500 MLD, all those costs, as I said to you, the operational capex costs are considerably high. Setting up the plant is not an issue, but maintaining it for the next 20 years is the concern that we're trying to address here. Also, the civil work that is required to take, let's say, from Andheri to my plant in Bandra, okay, the amount of civil cost that you're going to do for the piping, that's an exorbitant cost that we've not even taken into consideration. As Salvi Bhau mentioned some time back, once you treat that 12 MLD or 20 MLD, how do you transport that water back to the people? That's a tariff cost that we're not taking into consideration. A decentralized plant, we're talking about recycle and reuse at source. You treat the water at source, you recycle at source, and you reuse at source, right? Now, I'm going to hand it over to the man of the moment, Lalit. He is the guy who's going to talk to you completely about technology, and then at the later part, I'll come back into the conversation, right? So, Lalit.
Thanks, Rushad. Good afternoon, gentlemen. This is Lalit Bajare, and I will give you a technical know-how of FBTech, that is our patented and Jal Shakti Ministry empaneled technology. Actually, just to give you a brief of the technology, it started with Singapore. I had been a water treatment professional for last 25 over years. And out of that, I have spent 7 years in Singapore where I commissioned new water plants, wherein the treated sewage water comes to you for your drinking. And it is actually mixed in reservoirs. So I met few experts from United Nations, and the thinking over there was not to transport sewage from one place to another, as exactly mentioned by Dr. Kulkarni in his speech, that 60% of the sludge doesn't get to the STPs. So the thinking by the United Nations people, where I learned it from them in Singapore, it was that you should not carry sewage from one place to another. Instead of that, recycle and reuse it at source. So that would also add to your fresh water conservation. It will not be mixed with, it will not get mixed with your fresh water supplies like reservoirs, lakes, and rivers. So this is the empanelment journey wherein all the experts from IIT, DRDO, Niti Aayog, NIRI were involved in it. They have scrutinized it, and proudly we are the only Indian technology to have got empaneled with them. These are the credentials, empanelment letter, as well as the press release. So Jal Shakti Ministry had come up with a press release wherein they published it in English as well as in all the local languages and gave it to state governments. So we have it in Marathi as well. And in that, they urged all the state governments to adhere to this technology wherever possible. So this is the general flow diagram or PFD of the plant. So I'll just go back to a layman theory to explain what exactly we have done. Any STP or every STP is based on bacteria, and bacteria are not anything but a human being like you and me. Like we behave, bacteria also have all those effects based on environment. So in earlier days, we have our ancestral places, like our houses were horizontally spread. And when we were not left with any more spaces, we went vertical and developed flat systems. And exactly that is what we have done. We have given a fixed media, a flat system, which will provide more surface area per unit footprint or per meter cube for the bacteria to grow, thereby reducing the footprint of the plant. And at the same time, the media is fixed. It is arranged in that fashion that it is transportable, movable, and modular, and the media doesn't come out at all, or it doesn't get carried away or washed away. So you do not need any maintenance on the media, any replacement on the media for 30 over years. So this is the exact philosophy we have used. Like we have treated bacteria like we treat any human being. Now, the plant starts with collection, that is equalization tank, wherein it is generally an underground tank, wherein the wastewater is collected, this part of it, after screening. Then we pump it at equal or uniform, consistent, steady flow rate to the first part of the system, that is we call it biozone, and that is where we use fixed media. We have arranged it in such a fashion that all the units are modular and movable. Then and we have provided air for the bacteria. So bacteria lives on BOD, that is the food and the air, oxygen. Then from this chamber, the water goes to settling tank, that is the solid liquid separation happens here. From the top of the tank, the clear water flows to the chlorine contact tank, and from the bottom, sludge is collected at another tank. So this is all inbuilt. This is compartmentalized. Then we use dose chlorine for disinfection in chlorine contact tank, and the water is pumped to the sand filter. After that, after sand filter, the water is generally stored in a product water tank and then recycled for toilet flushing and cleaning. So this is just a guideline of the design philosophy. There are a couple of things that separates us from other technologies, that is using a fixed media and the air calculations as well. Generally in India, the air is calculated as zero point 0.6 kgs of oxygen requirement per kg of BOD. But we also take in consideration the BOD, the oxygen required for NH4 or nitrification, denitrification. Actually, it happens in another zone. That's a technical aspect. But this NH4 requirement, the oxygen required for the NH4 is generally missed out in STPs, and that is where it smells. So we are taking in consideration that as well. So this is the photo or the picture of our unit. Actually, one of the USPs is up to 40 KLD. All our plants are operated on single phase power supply. So generally in rural areas, you do not get three phase power. And that is where up to 40 KLD unit, this picture is 40 KLD unit, and it is just 4.5 meters in length and 1.8 meters in width. So that's our 5 KLD or 10 KLD plant would be as big as this table only. So these are some specialities or advantages, that it requires less space, then the power consumption is lower, it is movable and modular, and we are working as a Singapore style over here as well, that we are making all our plants 90 to 95% ready at our factory, dispatch it well tested, so that the civil work and the site work is also at minimum. So again, as I mentioned, one of the aspects is using fixed media, so no replacement is required. That leads to low operating cost, low maintenance cost, and single phase plants up to 40 KLD. Then these are some applications. Where can you use FBTech plants? So if somebody asks me, I have just mugged it up. Mandir, Masjid, church, railway station, bus stop. We have even installed it on a public toilet, schools, colleges, everywhere we can use these plants, government offices. So these are some of our installations. The first you see is on a public toilet, wherein there was a problem of mosquito breeding, bad odor, foul smell, and there were so many protests. So Sangamner Municipal Corporation went ahead with our solution, and they are reusing that wastewater, treated wastewater, for the same toilet flush. So thereby reducing the intake of fresh water and also avoiding all the bad odor or mosquito breeding or all the problems in the area. Then there are other installations like 200 KLD. That is our first plant that was installed in 2013, and it's a politically sensitive area, so not a single drop of water can go out. And that is where since last 12 years we are recycling 2 lakh liters of water every day and reusing it for toilet flush. So there are some installations like at religious places, which is an initiative by Rotary. So these are some plant variants wherein what capacity, it shows what capacity plant is generally needed at offices or schools and how much time it takes to deliver that plant. And then it comes to some circular impacts, which I believe my colleague Rushad will put a light on that. Yeah, thank you.
So I just wanted to add one more point that when we showed you the unit economics, there was a slide with the picture. We must consider two things. We have to realize that the way forward, and it's not something that we say it because it's a product, but essentially the way forward for sewage treatment plants is towards decentralized. This is a clear call. Sorry, this is a clear call that's coming from at a global level from UN as well. I think there was a lady from Rotary, I think at the back. Hi. You would be aware that currently your Rotary agenda, as early as a couple of weeks ago, has moved towards water preservation globally at Rotary International. We are in talks with the Rotary to talk about certain CSR events as well, wherein in certain districts we are tying up with them to have some kind of funding to do with a CSR. Let's say, for example, and I will use you as an example, sir, from Indian Oil. And if you have a CSR initiative, 50% of the CSR amount of the plant is supported by Rotary, and the 50% comes in from the corporate. So we are in talks of creating those kind of collaborations at a larger Rotary level, like Delhi, for example, where the corpus in the committee itself is up to 50,000, 60,000 crores. So the Rotary members themselves start sponsoring and kind of do these initiatives from their company sides. So we are looking at that point now. Coming back to what Mr. Muthu mentioned earlier, this initiative that we got to look at is we have to look at it from two sides. Number one, obviously, what we do for our planet and what we do as a business and what we're doing as a responsible operation in this community that we operate in. The most important factor is our clients should benefit from it. I now believe that this whole ESG ratings for all those companies that are qualified as early as 2023 has become mandatory. So you're responsible to publish your non-financial readings in your financial reports. Now, what we're trying to do is, if you as an organization, and this is, so essentially, I'll step one step back, we as a business look at three key revenue streams. Number one is obviously the government initiatives. Now, without me making it too vocal, we all know that for anybody, the government initiative will actually, in the long run, be the most lucrative because that is where the funds are. But the flip side of it is that those projects have their own challenges in terms of space, in terms of funding, in terms of the dynamics. So the gestation period for those, for those initiatives, the government initiatives, are slightly longer. The second problem for a business like us is we need to have a constant cash flow. So we are looking at institutional and commercial establishments. We're tying up with, new smart cities. We're tying up with companies who have their own centers. We're tying up with pan-India developers for the new towers. So that is something that keeps us going in the private sector. The third sector is where we're looking at corporates and major NMCs and corporations to tie up with them and help them support with the CSR initiatives. Now, this report tells you what a circular impact report for a product could be. Now, there is something called UN SDG goals. There are about 17 of them with about 167 action areas. I'm not going to get into the details of it, but let me explain to you what are the UN SDG goals that a simple STP plant that you put either in your factory or in you adopt a village can do for your organization. These are if you just by doing the first step, you have something called improved water conservation. I'm sorry, I can't see the cursor. Okay, there it is. Where my cursor lies, improved water conservation, recycling and reuse and recharge. What this does is, it reduces the risk of wastewater dumped into the water bodies. So you're creating a sustainable cities and communities. That's the SDG goal that you immediately impact. Climate action, obviously, and life underwater or below water, right? Now, for all the actions that you're doing, coming back to the point again with somebody mentioned about Rotary, I think Mr. Gulkarni, it was you mentioned about Rotary, that how they're looking at the bottom of the pyramid and try to create this kind of jobs for them. Now, you've ordered a product from me. I can give you an understanding of the amount of people that are required to actually set up that unit, whether they are on part-time or whether they're on full-time basis, and what's the revenue that you're generating. If you want to go deeper, you can even go to the extent of how many female as well as compared to male people, staff you've employed, and thereby affecting zero poverty and reduce inequalities. So I'm just giving an example as something as simple as a project that you undertake as a CSR. The amount of intangible value that it can add to your organization is tremendous, and it can be demonstrated from one slide in something we call a circular impact report, right? So I think that brings us to the end of our conversation, but before that, these are some of the brands that we have done business with in the past, some of the brands that we are currently doing business with as well, and some installations that we have currently on the way. In fact, Voltas has, there is a plant in Uttarakhand that we are putting up. And for Voltas, there's another plant down south also there's conversations for. Uh, this is us at the end of the day. I think I'll leave about 5 or 10 minutes if you have the time, Mr. Kulkarni, for any questions that there are, considering that this is a new product, and I'm considering there would be questions from a technical or other perspective. So thank you for your time. Thank you for your patience. Any questions? If you don't ask me, I'll ask you questions. I'm sorry. Sorry.
But you know, the problem is space.
Right. Sure, sir.
So, how you compare your technology with other competing technologies?
Right, sir.
You know, the popular technologies.
Mr. Kulkarni, sorry. Just sit down. You're giving me too much of respect. It's embarrassing me. Have a seat and ask me the question, please, sir. You sure? Yeah? I'm a little embarrassed. Thank you, sir.
So, sequential
Yeah.
batch reactor
Right.
and membrane bioreactor.
Right.
These are the technologies.
I think.
Which require also less space.
Right, sir.
Other technologies like MBBR, they also require
Larger space.
more space.
Right, sir.
So, where you fix your technology in that?
That's a brilliant question. I'm glad you brought it up, sir. So there are essentially, conventionally, there are 3 technologies that are playing in the market. MBBR, MBR, SBR. Now there is SBT and others also. Frankly speaking, we don't even look at them as our competitions, because for me, the only competition is Jokasu, because that's the only other product that is empaneled. Having said that, my presumption of my product has got nothing to do in the market. The most popularly used brands are these 3. Let me start with SBR. SBR is a technology which is used mainly for larger plants. It's a more suitable technology for plants that are 25 MLD, 50 MLD. Making plants at a smaller size is just not cost effective. Second, MBR. MBR is a technology that would give you considerably good output results. However, it is actually priced, if you do it the right way, if you make a real MBR without cutting corners, the way it should be, not compromising electricity, kam kar do, pump kam kar diya, wo sab nahi. As a MBR plant should be, it is at least, and I'm being very conservative, 30 to 40% more expensive than our product. Right? Operating cost, that is a separate thing. We are not even getting there because you have to flush the media and all that. So I'm talking about the capex. When you buy the product, it's 30 to 40% more expensive than us. Your operating cost is 40% more expensive than us for sure, because of the work that needs to be done on it. The only other product that you have now left is MBBR. So there was a minister in ULD called Harjit Singh Puri, and he came up with a white paper studies where he clearly mentioned, and I mean if the people from the BMC would also agree, MBBR as a technology is a failed technology. It really doesn't work. Why? Because there is no design philosophy. Right? Anybody is making an MBR. There is a philosophy of making a tank. You create all these parameters based on the BOD that you want to treat. MBBR is done the reverse way. They make the tank based on the capacity, they throw in the media, and that's about it. 100 KLD plant. My 100 KLD plant takes, the footprint of that plant is about 275 to 300 square feet. The same capacity plant in conventional technologies like MBR or MBBR would be about 450 square feet. So let me give you an example from a private player. Okay. A private payer who's a developer, in 150 square feet that he saves, he can give about 3 or 4 parking lots. Right? Parking's being one of the biggest challenge in Bombay today for all urban places. One parking lot goes for about 4 lakhs to 5 lakhs in a nice decent area. I've just saved you about unit economics on just the space is saving you 20 lakhs.
So your plant requires much lesser area than MBR.
Absolutely, sir. MBR, MBBR, for sure. Yeah. Yes. Absolutely, sir.
So how much percentage reduction in your plant?
I just gave you an example, sir, about 30 to 40%, 35% easy. In terms of operative cost also, that's the same difference that you get. Because in MBBR, there's a lot of other things like, flushbacks and all that you need to, membrane cleaning and all that, media replacement. We don't have any of that.
So your plant will satisfy NGT standards?
Yeah.
Absolutely, sir.
Definitely, sir.
BOD less than 10?
Yes.
Nitrogen, phosphorus?
Yes.
Absolutely, sir. In fact, I was just talking to Mr. Muthu, and that's another thing, Mr. Kulkarni, thank you for leading us into this conversation. In most of the other plants, as the plant becomes older, your treatment goals start diminishing. You have to keep working on them. Because we give you a fixed media is nothing but something that is fixed and a constant breeding ground for bacteria. Right? So, to give you an example, based on our design of the fixed media, we are giving you 250 square meters per cubic meter space for the bacteria to grow. Right? That's huge. That media is fixed. That means the bacteria is growing there. Bacteria needs two things for it to thrive. It needs food and air, oxygen. The food is the BOD that comes in from your sewage. And oxygen is the oxygen that is pumped in through the blowers into the biozone tank. Right? Now, as our equipment starts working for longer periods of time, the breeding of the bacteria increases. It's because it has a stable area for it to grow. Therefore, in our equipment, the older the product or the older the equipment, the better the results that you get, because there is more bacteria that has formed into the biozone tank, if that makes sense. So that is the philosophy, that's the process, that's the technology that was patented and empaneled by the Jal Shakti Ministry. If that answers your question, sir. Right.
Thank you.
Anything else? Thank you so much for your time. Thank you. Cheers.
Thank you.
Thanks to Mr. Lalit Bajare and Mr. Rushad Balaporia, sir, for this interactive session. Now we are moving towards the lunch. So the lunch is going to be at here only, the balcony area. So they will guide you accordingly, the outside people. Yep. Thank you.